Well, I'm going to explain the topic of this project. First, we have electric charges. It's not essential in the project, but it's information that helps us to understand better how things function. Matter is made by atoms, which are made by neutrons, protons, and electrons. Like you know, protons have a positive charge and electrons have a negative charge. This is very basic. All matter is not charged because there is a perfect equilibrium between electrons and protons. A charge occurs when this equilibrium breaks down by adding or removing electrons. Well, now finally we arrive to the important part, the explanation of capacitors. Capacitors are made to store energy. All capacitors are literally made exactly the same. Two pieces of conducting material that are not touching, never touching. For storing the charge, you need to connect those pieces of metal to a battery. Batteries have always two sides, positive and negative. Electrons will be attracted to the positive side of the battery, meanwhile the other side will be repelled by the negative side. The charge least on one side will always be gained by the other, and that will cause a perfect equilibrium, a perfect system that will let the both sides always be charged. Well, the truth is that this process is not as perfect as I said before, because the transfer of electrons won't happen forever. Once that happens, the process will be stopped and all the charge that was joined will stay there. That charge is sitting there, will generate a voltage. Another thing you need to know about capacitors is that all capacitors have a capacitance. That is the amount of storing charge, or better called amount of charge per unit of electrical potential. In other words, in formula words, capacitance equals to charge divided by voltage. This man was the one who discovered that. Genius. Now what happens when you have more than one capacitor? There are two different forms, series and parallel. Series is when all of the capacitors have the same amount of charge stored. It has a different voltage on each, and we use this formula. Parallel, in the other side, the capacitors gaining charge will depend on the capacitance of each one. They all have the same voltage, and we use this formula. Well, with this information, we understood our project, and I hope you also understand it.
A Leyden jar is a device for storing static energy. It is funny because it was discovered accidentally by Pierre van Mussenbroek. First, it was a simple glass filled with water, which the whole of this glass was closed with a cork, pierced, or with a wire, both touching and submerged. He needed to get the form of charge of the jar, so he used the other extreme of the cable touching a friction device that produced static electricity. The charge occurred when the cable separated from this device and he touched it. And this is how it all occurred, by a simple mistake.
It's our project, our Leyden Jar. So what we did was first gather all the materials that we were going to need. So we grabbed some cables, a little glass jar, and some aluminum foil, and some electric tape. So what we did first was cover up the jar with some aluminum foil as well as the ping pong ball. We did it as straight as we could. And the second step was we grabbed a nail like this long and we attached some of the cable in the bottom of the nail so that it could touch the whole water that was in the jar. We filled up the jar with water and a lot of salt in order for it to conduct more electricity. And after that, we just paste the ping pong ball to the little nail. And yeah, we grabbed some cables, we paste them in the jar, and the other one was connected to metal. And yes, this is our Leyden jar.
Creo que está bien ahí.
¿Qué tal tu nube?
Todavía no me
Ok, Felipe, empieza, tócala ya.
¿Segura?
No manches.
Vas. Ok, Pame, silencio en 3, Empieza a grabar en 1, 2, 3, ya.
Capacitor's function is literally to store energy. For explaining this, I will tell you a real-life example. Just imagine you want to climb the El Nevado de Toluca. You know you'll need a lot of energy for doing that hard work because gravity exists. When you climb, your body needs to go up against Earth's gravity. For this, how I've said, you will use energy, but this energy will never get lost or destroyed. Energy only gets transformed. That energy is stored in your body for doing other tasks well. This happens with capacitors. We have to charge positive and negative charge that will be attracted to one another, like your body to the earth because of gravity. When you are going up, you're separating yourself from Earth's gravity. That's why you need to put a lot of work there. So in conclusion, capacitors work when you need to climb something. They don't lose energy, they store it, charge, and get separated.
Assuming that the discharge is of 5 kilowatts, what is the average charge per roof? Well, we have 5 kilowatts that we need to convert that number in SI units. So, converting that, it gives us 5000 watts. Now we need to get the charge that is Q. With this formula, Q equals 2C times V. Well, our C is already converted into SI units, that is 1.5 times 10 to the minus 9. All that times 5000. That gives us 7.5 times 10 to the minus 6 Columbus. Well, finally, we need to divide that number between the times we rub the wall with the tube. And that is Q equals to 7.5 times 10 to the minus 6 divided by 20. That gives us our final product, that is 3.75 times 10 to the minus 7. Leyden jar is very used for experiments in an aula, but it is also used and very important as a capacitor's prototype. These are commonly used in televisions, radios, and other devices. And well, of course, for a project is used to show how can a device can store electricity. A curious fact is that a large Leyden jar can kill a human. In fact, Benjamin Franklin, to do it, well, he tried to do it with connecting a lot of Leyden jars and then generating a big charge. That are the uses for that we found of Leyden jars.